So today we are going to learn how to add linear expressions. And if you feel me getting a little excited, this stuff to me is like geekishly cool. I just totally love this stuff. It's the basics of algebra, and I just get all kinds of excited about it. This is going to be a little bit of a longer video. I have 6 examples for you, and I'm really going to talk you through a lot of the little tiny details. Today we are sticking with just adding, which only means that there's going to be an addition sign. We may do a little subtraction because there's going to be some negatives involved. But when we actually go to subtract linear expressions, this will have a subtraction sign here, and there's a whole different set of things that we need to do. Okay, let's talk about some vocabulary really quick. If we're talking about linear, what in the world does that mean? Well, it has the prefix, it's not really a prefix, I guess a root, a base, I don't know, something like that, of line, which is exactly right. If we were to graph these, which is a whole different topic, you would find that the graph makes a line. Well, how do you know without graph paper, without going through all that trouble, how do you know if something is linear or not? Well, all it means is that the exponent will only be a 1. None of these that you see in my examples will have an exponent today. It has a 1, but we don't write it, so we say it doesn't have an exponent. And then, of course, expressions do not have the equal sign. You'll notice none of these have an equal sign. There isn't another half to the problem. It's just the string of symbols and numbers and letters. Okay, 3 other words that I want to toss out to you that are not in your book, but they're fun to talk about when you're, talking math. These are binomials. Bi, of course, means 2, that prefix. So this has 2 pieces. You could have a trinomial, which would have 3 pieces, or you can have a polynomial, which means it could have any number, 1, 2, 3, 8, 16, whatever. Okay, so if you hear me say binomial, trinomial, polynomial, that's what algebra, when you take algebra 1, this would talk about adding binomials. Okay? All right, so let's look at our first problem here. We've got the quantity of 2x plus 3 plus the quantity of x plus 4. The parentheses in this case are just grouping things together. For this problem, they are not serving as a multiplication symbol. And, well, really, they're just a grouping symbol. Now, when I write these, I like to stack them vertically. You know, if I gave you a problem like 14 plus 18, you can write it so that the numbers are on top of each other. That's exactly what I'm going to do here. So I'm going to say 2x plus 3, and then I'm going to line up my x underneath, and I'm going to line up my other constant underneath. I typically do not write the plus sign, but you can. Now, just like I would when I had straight digits, I'm going to add the stuff. 3 plus 4 gives me 7. Remember, there's a 1 in front of that x. So 2x plus 1x equals 3x. And there is my binomial answer, 3x plus 7. You know, I can't combine it any further because the 7 is a constant. It does not have an x. And this has an x and the other one doesn't. So they're not the same. They're not like terms. Okay, let's go to example 2. Very similar, but now we have some negative signs or subtraction signs in there. If I read this, 2x minus 1, that's functioning as a subtraction sign. But when we go to combine these, this is actually going to function as a negative sign. I know, crazy. You'll get used to it. So let's stack these. 2x minus 1, the x will go underneath, and the 5 will go underneath the 1. Again, I'm adding. You can put the plus sign or not. I don't do it because when we do subtraction, you don't write the subtraction sign. That gets taken care of in a different thing. So it's just kind of a habit that I like to be consistent. Now, let's talk about -1 and -5 over here. Think back when we learned how to do integers and we did the chips. These are the same. These are both negative, so they would be the same color, which means I can just push my piles together, and this gives me a -6. I know that looks like a subtraction sign. I know it looks like a negative sign. Just roll with me on this, okay? So I took those two kind of as their own little mini problem. And then the sign of the number also functions as the linker sign in between. Just like up here, 3 plus 4 was +7. Well, that became a +7 or a +7 there. It's the linker between the terms. Same thing happens down here. Okay, let's do another little mini problem. I've got 2x and 1x. They're both positive. They both have the same variable, so I'm going to squish them together, and I get 3x. Well, there's my answer. 3x minus 6. That's as far as I can go because, again, this one has an x, a variable, and this one does not. All right, one more before we get into the next level. Again, we got some negative signs happening here. Let's stack these. 2x minus 3, negative x plus 4. And again, this is one of the reasons that I don't usually put the addition sign out here because I've got a sign and then is it plus, is it subtraction? We just kind of take the signs with it. Okay, let's do our mini problem. So I have -3 and +4. They're different. Some of those would be red, some of those would be black. So because they're different, I need to subtract. 4 minus 3 is 1. Which pile was bigger? The 4. That was a positive, so this keeps the positive. That's really an integer problem, not so much an algebra problem. All right, let's switch over here. So I have a +2 and a -1. Remember, there's that 1 in there. So again, they're different. We have some black and some red. Because they're different, I have to subtract. 2 minus 1 is 1. Of course, we keep the x. The 2 was the bigger pile, and it was positive. So we'll keep the positive for my answer. Usually, you're not going to see a positive and a 1. Usually, you would see this just as plain old x plus 1. But this line would not be wrong. That's perfectly fine, just not common. This is more of what you would see. So a couple things. Stack them. Make sure that you're lining up the same terms. Your x's are together, your constants are together. And then create these little mini problems for yourself that are more like integer problems than they are the algebra. Good? All right, let's go to the next level. You get a little bit of a wicked laugh. Bwahaha. We'll save the bwahaha for that one. Okay, this one has an extra step before I stack them. Here, the parentheses are actually showing me that I've got a distributive property happening. The 2 is being multiplied by the x plus 3. So let's do that first. We'll give out that 2. We turn it into 2x plus 6. Make sure you multiply that second term. And then the second part stays the same. You put the parentheses to group them or not. Totally up to you. Now I'm ready to stack them. I'm going to switch colors for this. So 2x plus 6 and 3x plus 1. Lucky us, there's no negatives in sight. This is an easy one. I can do the 6 plus 1 is 7. They all happen to be positive, so I'll put that sign as my linker. And then 2x plus 3x is 5x. So my grand final answer is 5x plus 7. Do you remember what word that was? Something nomial. Do you remember the prefix? That is a binomial. It has 2 pieces. You could also call it a polynomial, but the binomial is a little more specific. All right, let's go on to number 5 here. This one might get a little bit of a wahahaha. This one, there's some negatives. There's distributive property all over the place. This makes me so excited. I love problems like this. So our first step is to distribute. Now there's 2 different distributions that have to happen. The 5 has to go to the x and the 4, and the 3 has to go to the 2 and the 7. And I've already run out of colors. Oh, we'll go to light blue. Let's see if this works. Okay, so 5 times 1x is 5x. 5 times -4 is -20. 3 times 2x is 6x. 3 times 7 is 21. These were all positives. Now, I could put a little plus sign in here. Generally, I don't. I probably should. Okay, now I can stack them. 5x minus 20, and 6x plus 21. All right, so let's do our little mini problems. I've got a negative 20 and a positive 21. They're different. I'll have some black chips and I'll have some red chips. So I know I need to subtract. 21 minus 20 is 1. The bigger pile was the 21, so it's positive, which means I'll keep the plus. Trying to keep the paper straight there. Okay, let's go to this one. I've got positive 5x and positive 6x. They are the same, so I can simply add them and keep the variable. My grand final answer is 11x plus 1. And that is as simple as I can make it. They are not like terms. They cannot be combined. All right, that's pretty much all of the different levels of difficulty that you're going to see today. There is one more problem that I want to do with you, and it's an application of it. Okay, so you're going to have a picture, in this case, a triangle, and each side is going to have some measurements. Now, 3x minus 3, I've never seen that on a ruler. It's not really a measurement. It's more about a relationship. This side, and it's all related to x. Anyway, we want to find the perimeter of this triangle. And the perimeter, of course, is like the fence where we add up all 3 sides. So let's start off by writing the expression. We've got 3x minus 3 plus 2x plus 9 plus 5x. So a triangle has 3 sides. I have to make sure I have 3 pieces to my expression, and I do. So now when I'm ready to add them, I'm going to stack all 3 of them. Oops. The 5x will go with the x's, and then this will just be blank. If you really want to put a placeholder, you could put a 0 there, but you have to make sure that that x goes with the other x terms, and the constants stay together as constants. Okay, so let's do our mini problems. I am going to put a 0 in here just for organization. So I have a negative 3, a positive 9, and then 0, which really isn't going to affect my calculations. These are different signs, some reds and some blacks, so I'm going to subtract. 9 minus 3 is 6. Sorry, I got the shadow going here. The bigger pile was 9. It was positive, so we keep it in front, positive in front of the 6. Now let's shift over here. I have no negatives anywhere with those, which is great because I can just add them all up. So 3 plus 2 is 5. 5 plus 5 is 10. Keep the x. The perimeter of this triangle is 10x plus 6. Now, without giving a whole other lesson, that is a relationship, okay? Maybe these are bricks. And whatever size brick I pick, this is the measurements that are going to come out. So if I pick a smaller brick, it's going to give me a smaller triangle. If I pick a bigger brick, it's going to give me a bigger triangle. So this is the type of problem that you're going to see. They follow it up with, ready? What if x equals 5? Now, you could have done that from the beginning. If you saw this, you could have said 3 times 5 minus 3, 2 times 5 plus 9, 5 times 5, and put it together as just numbers. But we didn't, because I love the beauty of a variable. Maybe the one brick is 5, but maybe another brick is 17. I don't want to recalculate this every time. This is going to be like 2 steps as opposed to what? 1, 2, 3, 4, 5, 6, 7, 8, 9 steps? Yes, I will take this any day of the week. Okay, so as a separate piece of our problem, we're going to have 10x plus 6, and we're going to replace that x with a 5 because it said x equals 5. This is a time sign, a dot. So 10 times 5 is 50. 50 plus 6 is 56. I don't know. Let's say that these are units because they didn't tell me what it was. So whatever measurement, centimeters, inches, feet, whatever, it would be 56 of those units if x was 5. If x was something else, this would be a different answer. So there's two answers to this problem because there's really two things they're asking for: an expression for the perimeter and then an exact value based on a what if situation.